Happy Thanksgiving, everyone. This is my little gift to you. I'm going to do 2 problems from your Chapter 9 homework for you, with you. Number 9.1, it says a random sample of 85 group leaders, supervisors, revealed that on average a person spent 6.5 years on the job before being promoted. Basically, you're supposed to create a 95% confidence interval for the mean. So basically you're looking at, we're 95% confident that the true mean time a person spends on a job before being promoted is between certain bounds. So you will go to megastat, just showing you. Now remember, if you're doing it the way it does in the workbook, that's fine. I'm just giving you the shortcut. Megastat, confidence intervals, megastat makes it real simple. Confidence interval for the mean, that's your first option. Just tell it the sample mean, which is 6.5. Tell it that you're running a t interval. So basically, you're running a t interval whenever you don't know the population standard deviation. You know the sample standard deviation, which is 1.7. And we're just retrieving this information from the paragraph. And you know the sample size, which is 85. And you want 95% confidence interval. All you have to do is hit OK. And so this is the answer you will be retrieving. And then you would just say, I'm 95% confident that the true mean time before being promoted is between 6.1 and 6.8 years on the job. Okay, I'm going to hit pause here a moment and move to problem number 4, 9-4. I'm jumping around a little bit. Okay, now you notice in 9-4, it wants to know how large of a sample size is needed to obtain a certain desired margin of error. It says the estimate of the population proportion is to be within plus or minus 10%. It's kind of like when you hear the polls and they say the margin of error is 3%. It's kind of like if you have a desired margin of error, how large a sample do you need? How many people do you need to poll to obtain the desired margin of error? So it says how large of a sample is required. So all you have to do is go to megastat, and again, this is a shortcut to what the workbook tells you. Down to confidence intervals, and then sample size needed P, that means for given proportion. Click that. E is the desired margin of error. You're just going to hit 0.10, and it says the best estimate of the population proportion is 0.45, and confidence level is 99%. And you just hit OK. 96 would be the answer to that one. So that's my I'm going to hit pause again. Okay, and I'm also going to quickly do 10-1 with you. The null hypothesis is that the mean wait time for McBurger restaurant, the mean waiting time for the customers is 3 minutes. So that's our null hypothesis. Our research hypothesis is that the mean wait time is less than 3 minutes. So the question is there enough statistical evidence to say that the mean wait time is less than that which they claim, which was 3 minutes? So our sample mean is 2.75. Notice how I ordered this. You can imitate how I'm doing this for your homework. The golden rule for research is if your p-value is less than your alpha, reject the null, thereby favoring your research hypothesis. All of this information is more heavy duty in the lab when you do the video. So I'll just remind you, you go to megastat, you go to hypothesis test, go to mean versus hypothesized value. Okay, so you go to megastat, hypothesis test, mean versus hypothesized value. Summary input, highlight all of this, including the name McBurger. Hypothesized mean is 3 minutes. We're running a less than test, a left-tailed test, t-test. Confidence level at 95%. Hit OK. P-value is less than your alpha level. You're going to reject the null in favor of your research hypothesis. Okay, good luck, guys.